We have started recording. Okay, there's a little delay getting the recording started, but we are open for business now. I want to welcome all of you to the Popular Astronomy Club February meeting. And okay, you just need to find out why I'm not advancing here. Here we go. Okay. Screen set up here. For tonight, I want to welcome all of you. We have a few people here, about 8 of us here in the meeting, and looks like we have at least 18 more online. Also want to welcome some of the surrounding astronomy clubs here. We have potentially members who've been invited from Cedar Amateur Astronomers, Peoria Astronomical Society, Quad Cities Astronomical Society, Rockford Amateur Astronomers, and Twin City Amateur Astronomers. So, you have most of you have been very helpful in inviting us to some of your presentations. So we are welcoming you to join in with ours tonight. For our agenda, we will have our featured presentation, which I'll introduce in a minute. After that, we will have an opportunity for questions and answers. And then we will talk about some observations from our members and have a few announcements and preview some coming activities. So without any further ado here, we will move right in to our featured presentation for tonight. And Owen will be telling us about how the birds use the night sky. So we're not the only astronomers around. Dr. Jen Owens is an associate professor in the Department of Fisheries and Wildlife at Michigan State University. She directs the Michigan State Bird Observatory that runs 2 long-term migratory bird banding stations in mid-Michigan, the Bird Lake and Corey Marsh banding stations. She and her students are currently studying how variation in habitat quality and access to adequate food affects a bird's ability to meet the demands of the migratory period. Additionally, they are dedicated to connecting people of all ages to nature through the wonder and beauty of migratory birds. And tonight, we will learn a little bit about how the birds do their own astronomy with her presentation, Seeing Stars, How Birds Use the Night Sky During Migration. With that, I will stop my sharing and turn it over. Welcome, Dr. Jen.
Great, thank you, Dale. Thank you for having me, and just give me a second while I share my screen. So I am hoping you are seeing my screen now. And is the audio okay?
We hear you loud and strong.
Perfect. And I'm just going to give one warning that my microphone sometimes changes in between my Zooms these days. So I might go mute, and if someone notices and I don't, will you please interject and let me know? So the wonders of Zoom. All right, well, thank you. I'm really excited to be here. I should point out, I am not an astronomer. As you introduced me, I am a migratory bird person, but it's amazing what birds do and how they use the stars, how they are astronomers. And this actually talk that I'm giving you is one I designed actually to give in a planetarium. So we were doing this talk where we could manipulate the planetarium itself to illustrate how scientists had actually discovered or learned about how birds use the night sky. It's just an amazing integration of biology and astronomy and advancing our knowledge about migratory birds. So migratory bird migration in general is just truly phenomenal. So here in North America alone, billions of birds each year will make annual migrations between their breeding grounds in the north temperate regions and the southern warmer tropical regions. And over half of the 650 species of birds in North America are migratory. And these annual migrations are truly epic. And even studying it for over 25 years, I'm still in awe of what they do and how they do it. Appreciation of the feats of migratory birds is well expressed by Frank Chapman, who is an ornithologist and curator of the bird collection at the Natural History Museum for most of his career. And in his book, The Travels of Birds, he says, birds are the greatest travelers in the world. Now, while it's true that humans make longer journeys than birds, humans could not make them without the help of others. The bird traveler asks for help from no one. No use for locomotives, automobiles, or steamships. They carry no chart and no compass, and they can go with ease to parts of the world which took many years to reach, and to some parts of the world that are still unknown to us today. Not only are birds the greatest of aviators, they are also the greatest of travelers. So each year, billions of birds will depart their nesting or natal grounds in the fall and migrate south to their wintering areas, going as far as southern South America. In fact, on average, 4 billion birds will cross the US-Canada border in the fall, and another 4.7 billion birds will leave the United States over the southern border, heading into the tropics. And for many birds, this is their first migration. So what you're seeing here, this map, this is a map that's actually generated by citizen science. It's called Through eBird, which is operated by the Cornell Lab of Ornithology. And each dot on this map represents the average location of all individuals for a particular species. So each dot is a species, basically, that population, and where they are throughout the year. And so what you're seeing is birds leaving in the fall, it's December, they're going all the way down to southern South America. So January, they start moving, February, moving even more, so they're moving now. And then you can see the speed of migration speeds up. And then look when they get to the boreal region, how fast they turn around and start heading back. And again, this data is all done through citizen science. Now, when we think of bird migration, many people have this image of geese flying in these V-shaped formations. And in fact, you will frequently see these formations during the migratory period.
Yeah, they use the moon and the stars.
But far more birds, hundreds of millions, are flying over you at night, as shown in this Charlie Harper painting from 1990. And if you're very quiet, and I don't know if you can hear this, and if you look at the moon face there, you'll see some birds hopefully flying across it. And if the audio is working and you can hear these sounds, this is the sounds of birds flying at night. These are thrushes. They have a unique call. And you can hear this if you watch them during the migratory period. And just be quiet and listen. You may hear the flight calls of birds overhead. And if you can use a telescope or even sometimes just binoculars and look at the moon, particularly when it's at or near full, you may even see birds flying across the moon's light. Now, the ability to observe birds as they cross the moon's illumination is likely to led to the observation that an English minister and scientist, Charles Morton, who in the 17th century wrote a surprisingly well-reasoned, though obviously totally inaccurate, treaty claiming that birds migrate to the moon and back every year. That's right, to the moon and back. And Morton was even aware of how epic this journey would be. He estimated that a one-way trip to the moon was 179,000 miles, 179,712 miles. Now, he wasn't actually that far off because the moon, as probably many of you know, the moon varies between 226,000 to 252,000 miles away on account of its elliptical orbit. And he reckoned it would take the birds about 60 days to make this journey, flying at a dizzying 125 miles per hour. And the reason he reasoned this is because birds seem to disappear entirely during the winter. And the only logical conclusion is that they must set off into space. So now whither should these creatures go unless it were to the moon? Well, we know that birds don't fly to the moon, but they do make some pretty incredible flights. Arctic terns, the species that makes the longest migration on Earth, travels on average 43,000 miles round trip each year between the Antarctic and the Arctic regions, making a couple stops to refuel along the way. And over their average lifespan of 30 years, they will have traveled the equivalent of 3 round trips to the moon. Bar-tailed godwits, a shorebird, they can fly for 7,000 miles. That takes 8 days nonstop without stopping once to land. But these epic adventures do not just belong to sea and shore birds, that even small songbirds make long distance flights. Sorry, there's one thing that just a message that popped up and I wanted to make sure people could still hear me.
Yep, yep.
Good, thank you. Sorry, it just, I got an error message.
Okay, fine.
Great. So these songbirds also make epic flights. So this one remarkable species of songbird, the black-polled warbler. So this one that in the picture weighs as little as 2 quarters. And it will double its body mass. So it weighs 12 grams. And within a matter of a couple weeks before migration, it can double its body mass. It literally becomes gushy with fat. They literally are. When you're holding these, and we capture these at our banding station, they're just mushy with fat. And they'll depart from the Gulf of Maine, and they fly for 86 hours nonstop, covering 2,000 miles. Now, birds such as the black-polled warbler, if they're over land, predominantly migrate at night. And we hear and we see them, but why would they do this? Well, there's quite a few reasons why songbirds, these small songbirds, will migrate at night. And it's actually some of the same reasons that we see raptors and hawks migrating, vultures migrating in the day. The atmosphere is much more stable in the evening than it is in the day. It's cooler, so reducing the risk of dehydration. Predators don't do as much feeding during the night as they do in the day, so it's safer. And then they have the day to feed and rest. And they're doing this at night, but they are to cross over an ecological barrier such as the Gulf of Mexico or Lake Erie or the Saharan Desert. They will migrate throughout the day. So what does a night look like? Well, we've actually had infrared cameras set up so that we could see the trees at night, and you can see the bodies, the heat of the body of the birds. And right after the sun sets, they go through this period of quiescence. It's a quiet period for about 30 minutes. And then you'll start to see the birds as they start to move towards the tops of the trees. And then they'll actually take off, they'll lift up. They usually go into the headwind, and then they move into the appropriate direction flying. And they'll migrate usually until about 2 a.m. on average, and then they'll land and rest and feed. Unless, again, like I said, if they're over a large body of water, they'll just keep on flying. Even a hummingbird can fly 30 hours nonstop over the Gulf of Mexico. So envision an indigo bunting as shown here. And mostly what I'm talking about today is about birds in their first year. So this bird is going to hatches in the summer. Let's see if I can get my mouse over. So it's going to hatch, and then it's going to physiologically change and go through a period of what's called hyperphagia, where it'll start eating at a very high rate and they'll deposit that food in the form of fat. Now, no one's telling it, its parents aren't telling it to do this. It's just physiologically changing. And then it will migrate to its wintering grounds. Now, again, this bird just hatched this summer. It does not follow its parents. It doesn't follow anyone. It is born knowing the distance it needs to go and the direction it needs to go. And it will leave at the particular time of year in which indigo buntings in general will depart. So this migration is innately programmed. So in this map here, you're seeing the red is their breeding areas, the blue is the wintering areas, and the yellow is where you would see these birds during migration. And again, the indigo bunting is born knowing it needs to migrate. It's born knowing the direction it needs to go and how long it needs to fly to get there. So how do we know this? Well, this is the beauty of observations. Anyone can make observations. And actually what this knowledge started really with bird fanciers. So you've probably seen in movies where people liked having their larks, or they liked having the nightingale singing. So they would take those wild birds and they'd have them in cages so they could hear their beautiful vocalizations. Well, it was during these, when people had these birds in cages that were from the wild, that they noticed that at certain times of the year, these birds would get really restless. They would hop up and down in their cage, flutter their wings, and it was at night. And it was at the same time of year in which other birds of the same species were migrating. And so this apparent urge to move at night corresponds with the distance and circannual rhythm of migration of the same species. And the term, this was coined Zugenruhe, so the German term, and it was first published in 1707 by Johann Neumann. And he interpreted this Zugenruhe to be an expression of the migratory instinct in birds. Not only do they exhibit this restless behavior, this activity in a cage, but under the correct conditions, they'll actually display the behavior in the right direction that they should be flying. So what you're seeing here are these, what they look like, big ceramic bowls, and you have white-crowned sparrows in them, and they have access to the sky, but they're round, as you can tell. And these birds are going to exhibit Zugenruhe. They're going to hop up and down at night, but they're going to do it in a particular direction. And so this was these round sort of, what they're called as orientation cages, or Emlyn funnels, named after Steve Emlyn, who was a professor at Cornell University, who designed these. And what it, again, it's this funnel round, and in this picture, what's showing here is that on the left, you have a bird, and in the middle, and at the bottom of that cage is a ink pad, it's non-toxic ink. The bird will hop up and down on it. And then surrounding that cone is a piece of paper, white paper. And so whatever way the bird hops, what direction, you'll see an ink blot. And so if they're always hopping in the same direction, as you can see in this one picture on the right, you'll see the ink blot only in one area. Now, if they weren't showing any orientation, any behavior, they would be ink blots probably all around this piece of paper. And so what they found is that birds actually did. They hopped in the seasonably appropriate direction. In the spring, you can see on the left that the birds, the ink blots, were pointing towards the north. And in the fall, those ink blots are going towards the south. So a pretty remarkable discovery and an amazing tool to allow us to learn a lot about migratory behavior. Now, while I don't study actual orientation, I do a lot of work with Zugenruhe, migratory restlessness in birds. Now, if the birds were in a building, a steel plated building and no access to the night sky, they cannot actually show this behavior. So that tells us that there's cues that they're using. So how do they know the direction? What compass are they using? They don't have GPS units or smartphones, but yet they clearly have a compass. Because again, the bird on their first migration, they do not, again, follow anyone, but they know the correct direction and distance to reach their wintering areas. So they do this with multiple compasses. And I'll explain why this is so, well, you probably can imagine why having multiple compasses is so important. And those include the sun, basically where the sun sets, polarization of light, stars, and the Earth's magnetic field. And of course, because I'm here talking with you, I'm going to be talking more about the star compass. So it became clear that birds were using stars through actual planetarium experiments. I always just find this remarkable and how incredible it is, this, again, this integration of the sciences of how we can learn about the biology of birds using planetariums. Now, some of the first experiments were by Franz and Eleanor Sauer in 1957, and they did demonstrate the use of stars for navigation by birds. Because what they did is they brought these garden warblers, the European warbler, into a planetarium. And first, they found if you had just put a bird in there with no stars in the planetarium, then they weren't going to show, they didn't show any direction. So what you're seeing here is computerized. Instead of the ink, you're basically seeing where the bird was hopping in these black circles here. So what you're seeing is the direction. There was no particular direction of where these birds were hopping. But if they gave the birds access to the night sky and they simulated the sky the birds would see in the wild, so they would show them the sky they would see in spring, and then what the birds would actually move, they would hop in the direction that they should be going in spring, and vice versa in the fall. If they showed them simulated the sky for fall, what they would see, that birds would orient in the correct direction. But there's one caveat here. They did not display this behavior if it was silent. So the accurateness quality of the planetarium, they needed to actually mask this to make it seem a bit more real. And so what they did is they played snowy tree crickets in the background. So this was surround sound, so it wasn't directional. It just, so that it's not like the birds were orienting towards the sound. But only when they played these crickets and showed them the correct sky did the birds actually orient in the correct direction. Now, how are they using the stars for orientation was the big question. So we know the stars are important. So what part of the sky were they using, and what part of it were they born knowing? Because these are birds, again, on their first migration, and they're using the stars and they're orienting correctly, given without any prior knowledge. One hypothesis is that the birds were born with an innate knowledge of the constellation map, that they were actually born knowing that Polaris is the North Star, and that they memorize all the other constellations. Now, the experiments didn't support this hypothesis, because if they kept the sky stationary and not the natural celestial rotation, they could not exhibit, the birds did not exhibit any activity in the appropriate direction, even if that sky was seasonably correct. So it was clear that the Polaris was important, the North Star was important, but what they weren't sure is, what were they born knowing? What aspect of this sky did they know before? genetic, like what was an innate. So what is unique, as you know, about Polaris is that its position never changes. It's the center of celestial rotation. And so the stars and the constellations are rotating around this fixed point. So if you look at the sky at 9 p.m. and then again at 1 a.m., the other constellations have changed, but Polaris is fixed. So again, would birds have this innate knowledge of Polaris? Well, that seems counterintuitive because I don't know when it is, but I would think it's like every 25, you probably know more about this than I do, but every 25,000 years, the bird, that there would be a new North Star. So it's not always the same North Star. Oops, right, I did not mean to do that. So Steve Emlin decided to do an experiment to test to see if you changed what star was the fixed point, the center of celestial rotation, would that affect the orientation behavior? So this experiment used Polaris, the normal sky being fixed, and then the other sky used Betelgeuse as the center of the celestial rotation. And this is what I think so cool about the planetarium is that you can actually manipulate the planetarium to do this. So this is a picture of that experiment. So what you're seeing here is the scaffolding in this is the Robert Longway Planetarium in Flint, Michigan, where he did these experiments in the 1960s. So here's the scaffolding, and then you'll see along here are the orientation cages, okay? And then these were indigo buntings that were the birds that were used in these experiments. And these birds are actually hatched and raised in the planetarium itself. So they never had seen the natural sky. They've only seen the planetarium sky. And so they had 3 groups of birds. They raised one group of birds under a normal sky. That's what they were raised with. That's what they saw every day. Then they raised a group of birds with no stars. They never saw any stars. And then they raised a group of birds that saw Betelgeuse as the stationary, the fixed point, and then the constellations rotating around it. And again, you cannot do this experiment when it's silent. So we had to do it with the snowy tree cricket. So what they found is then they took the birds, they were all raised in these specific treatments, and then they exposed them to the real sky, the natural sky. And the birds that were raised with the normal sky, they were able to orient correctly. But then the birds that were raised with Betelgeuse as the fixed point did not, because they did not, they learned the wrong star, the wrong constellation map. So they took what they found is through these experiments is that the innate knowledge is that the fixed point, the center of celestial rotation is the north. And then they use that to learn which one star that is, and then all the constellations around it. Then they learn the constellation map. Now I said there's multiple compasses, and the magnetic compass is incredibly important too. And I'll explain in just a minute how these work together, but so the liquid metals, right, in the Earth's outer core are highly magnetic, and they're responsible for creating the magnetic field. And this works like a shield surrounding the planet, repelling and trapping charged particles from the sun. And then running through the atmosphere between the 2 poles are these invisible longitudinal lines of magnetic force. And they circle the globe like sections of an orange. And the birds can use these magnetic lines to orient. So at the equator, the force lines are horizontal to the Earth's surface. And I don't know if this red is going to show up on your screen. We'll see. So they're horizontal to the Earth's surface, but as you increase in latitude, They dip into the earth more strongly as you approach the poles. And this is the angle of inclination. The length of the arrows is positively corresponds to that intensity. And birds are able to actually use this inclination and intensity to get a cue to latitude and direction, but in relation to a pole in the equator, whether it's poleward or equatorward. They don't distinguish between north and south. They only distinguish whether or not they're going towards the pole or towards the equator. Birds have multiple compasses. I mean, you can imagine and sit there and envision many reasons why. Well, what if it's cloudy? They still need to orient in the correct direction. And the stars, the constellations may not be visible. You also might be thinking, what are they going to do in the southern hemisphere when they can't see the North Star? How are they going to orient? And here the magnetic compass becomes more and more important. But many night migrating birds will take off with a setting sun to which they calibrate their magnetic compass, and then they use their star compass to maintain this established heading. Now, one reason to not be born knowing that Polaris is the North Star is that the North Celestial Pole shifts as the centuries go by. And since it takes about 25,000 years for the Earth's axis to complete a single wobble, different stars have become the North Star at different times. For example, the star, I think it's pronounced Thuban, I'm probably pronouncing that wrong, in the constellation of Draco, the dragon, was a North Star around the year of 2600 BC, during the age of the pyramid builders of ancient Egypt. And it's estimated that around 14,000 AD, the Earth's axis will point reasonably close to the star Vega, one of the brightest stars in the sky. So potentially, perhaps, the future descendants of birds will confer the title of North Star on it. So I shall try to tell you how they prepare for the journey, how they find their way, when and where they go, and how they get there. I shall be but a poor historian if I don't arouse in you so strong an admiration for these skillful voyagers of the air that you'll give them a hearty greeting when they come in the spring and wish them luck when they leave in the fall, as said by Frank Chapman in The Travel of Birds. And with that, I wanted to say thank you.
Thank you very much, Lynn.
I leave lots of time for questions because usually there are, so.
Remember, if you ask a question, you have to unmute yourself first.
I wanted to tell you that it was very fascinating.
Well, thank you. I appreciate that.
I even have my husband sitting here watching.
Yes, interesting. I know birds migrate. They know
Yes,
the
fascinating.
direction to go.
I forwarded this to my grandson too, so I think he's watching too.
And I should say that, you know, I was talking about the birds on their first migration. So once a bird learns where it's oriented, and, you know, gets to a certain wintering area, and its subsequent migrations, it actually uses experience and knowledge and landmarks to make its way back north. And so it's really on that first migration that they're relying on that innate knowledge that that's being genetically programmed.
Wow.
So one of the questions is why, any reason why they need the night noise to orient? I think it's because it's not that they need that certain noise. I think it's that it seems like an artificial environment, and that is, I mean, I'm not sure exactly, but my guess is because it's just too artificial without having any background noise, because that just wouldn't be normal. I know that when I have doing experiments with Zuganru, just looking at migratory restlessness, not in orientation, we need to have a moon. And if it's completely dark, the birds won't move. We have to simulate the moonlight.
Yeah. So what's interesting is that how do they even know what's normal? Being born in the planetarium.
Well,
yeah. Okay. Right.
yes, and that's why the birds that were, born in a planetarium, I mean, when in the planetarium, right, the sky is simulating the natural rotation, right, throughout the night, and it's mimicking what the birds would see outside. But when they don't get access to a normal sky, then they don't have those correct, they don't have those abilities to orient correctly.
Mm-hmm. So yeah, so the what's natural must also be programmed, the sounds and so forth.
Yes,
For
yes.
them to respond. Yeah.
Yeah.
Okay, thank you.
Yeah, you're welcome.
Good.
They won that Audi.
Oh, my goodness.
Got another question?
Can we ask questions?
We have a question here from the audience here at Butterworth.
All right.
Yeah.
Have the ornithologists noticed the effect of the man-made lights that are increasing over the decades on the birds?
Yeah.
Patterns?
I'm not sure about migratory patterns, but mortality, it is a huge, huge issue for migratory birds. They are attracted to the lights. The lights do disorient them as well. And so that's why, I don't know if you're familiar, there's a lot of lights out programs now across the country. So during migratory periods, so which is usually, for this area would be, right, April and May, and then August through early October. There's actually these lights out. So after 11 p.m., they turn out the lights in skyscrapers. They're changing how the lights on towers are actually, the blinking, the how often they blink and the pattern of blinking. Anything to reduce that disorientation or attracting the birds towards it, because the amount of birds that die from hitting skyscrapers is pretty, it's huge. So yeah, the light pollution is a big deal for migratory birds.
I have one question to myself. Since I know you ban birds and follow their migration, yeah. If birds, and typically spring or fall, we might have some very bad weather, say a hurricane or something, where the birds might not see the clear sky for a week. Do they lose track of their actual path and make mistakes, or?
Well, yes. So that's a cool question. And there's multiple things that are interesting. So one, when you have a hurricane, the pressure's dropping quite a bit, right, beforehand. The birds sense that pressure drop probably before we do, and they typically actually don't migrate. They'll actually just sort of stop wherever they are. I used to ban birds in Alabama and Louisiana, and all the birds would stay sort of congregated up in the northern latitudes, which, by the way, we can see from radar, Doppler radar. You can see birds on that. That's a whole nother talk. So they may not migrate, but what we have found is that sometimes in those strong storms, you do get birds that get blown off course. So they might be orienting a particular way, but they end up someplace else. And what we find is if that was the bird's first migration, that bird will learn that place they got to as the place they were supposed to be. Then that's the place they will return to. If it's an adult bird, it's not their first migration, they can correct for it. But a first-year bird typically doesn't correct. And so they will constantly go back to that same place year after year. I don't know if that answered your question, but.
Yes, I think that was very interesting. How can we make use of that bird information, particularly detecting such things as the air pressure, and feed that to some of the weather forecasters around here? Don't seem to detect that well.
That's right. We need birds telling us the weather.
Hey, we have some questions out in the chat also.
Okay.
We have one here from Peoria Astronomy Club. You mentioned constellations as a guide for the birds, but aren't they man-made?
So I'm not sure I understand the question on that.
I'm assuming, if they're still on, they can maybe just go ahead and ask the question. But I'm assuming, constellations are human constructs and constellations are not real. The stars are real, obviously, and those patterns are human inventions. So how birds
Right.
actually looking at it there.
So, yeah, so I say constellations or whatnot, but obviously the birds aren't saying, oh, I know, that's the Big Dipper or whatnot, but it's basically, they're just knowing the stars and the pattern, the map of the stars. They don't know their specific constellations, just like they don't know the name Polaris or whatnot. They just know. That's why just understanding that fixed point, right? That they need to know that in order to basically understand how to use the stars for direction. But they don't know the constellations. That is correct. It's just easier to explain it that way.
I actually had a thought when you were talking about that, whether the experiment with the planetarium where you're showing certain constellations, but could that be done as the astronomers do with certain magnitudes of stars, and maybe the birds are only looking at a certain magnitude or greater.
So you mean like maybe only
They'll have a star or two that outshines the others. So I'm just wondering if that might be a future experiment to look at how bright does a star have to be before the bird will migrate with it.
that's a good point. That is true. There is so much variation in that. And I don't know how much that plays into their behavior or how that affects, their orientation. But that's interesting. Yeah. There's another question I think I saw. I'm trying to, my chat keeps disappearing.
Yeah, there's one here. It says sometimes on spring, summer, or fall nights, you see and hear lots of birds in a single tree. All is this related to migration?
Actually, probably not. So when the vocalizations that you hear during migration, actually the flight calls at night, they're totally different. You would never hear those vocalizations any other time. It's only when they're flying and migrating they make those vocalizations. And actually you can identify species. So they have all over the country these recorders in all these different places, and they record those night sounds, and they can actually identify the species of birds that are flying over that night just by that vocalization. And birds are doing that to maintain. Birds don't fly in like sort of with their family or whatnot, but they do have what we call loose kind of flocks, and those calls sort of keep contact with each other. And that might change. They're not always with the same birds. In terms of birds, summer, fall nights, hearing a lot of birds singing, certainly in the spring, that's just when birds are getting here and they're getting ready to breed and whatnot, but not necessarily migration.
Okay. Oh, we have another question from the audience here.
Okay.
I was wondering why the indigo bunting was chosen for the experiment. Do you know?
Yeah, that's a good question. So there are a lot of different migratory strategies in birds. So I didn't get into that, but I don't know if have you ever heard of like snowy owls? Like some years you get lots of snowy owls coming south, or so certain birds will migrate because of food availability. So that's what we call a facultative migrant. But there's other species of birds, and primarily songbirds like the indigo bunting, that are obligate, that they're programmed to leave at a certain time of year when the day length is a certain length. So it's not like temperature changes or food availability changes. They're just programmed to go, and that is affected by photo period. And so you can't do these experiments with species that are migrating because of food. It has to be an obligate migrant. And also indigo buntings are very easy to work with in captivity. They're easy to take care of. And a lot of times these birds will then go into aviaries, like afterwards, like in zoos. Like I've done a Zuganru experiment, and then I have with ducks, and they're in zoos all over the country right now. So they're just easier to keep in captivity.
Very interesting. Thank you.
Yep, you're welcome. Any other questions?
I'd like to jump in with one if I could.
Sure.
All right. In the experiment where you had them exposed to the North Star, no stars at all, and then Betelgeuse, and then you further tested to see how they oriented themselves. Was that exclusively done inside a planetarium, or did you give the little critters a crack at the real night sky?
No, it was exclusively done in a planetarium. That's the control for the fact that you need to test the stars and not the magnetic compass. So if you take them out of the planetarium, then they're going to start using the magnetic compass a bit. So then they can correct for it. So that's the thing. If you're trying to isolate and look at just one compass, you have to not give them access to those other compasses.
Can I have a piece, please, Lenny?
Yes, is there another question?
Pretty fascinating, huh?
So it's cited research is vintage. Yeah. So someone asked is whether or not the research, so Steve Emlins, there's folks, colleagues of mine, particularly in Germany and Sweden, who are doing a lot of amazing work, particularly with the magnetic compass. I don't know as many experiments are working in planetariums and the stars. There was quite a few for a while that were doing that. And it seems that scientists have really learned a lot about sort of how the birds are using the night sky. What really has been the mystery is how are birds detecting a magnetic field? And so trying to actually work with that, trying to figure out what it is that is in, there's sensors, neurons, and there's magnetite that's in their beak, different ways of them sensing the magnetic field. So I don't know if that answers your question, but most of what scientists are working on is trying to understand magnetic field. And the other thing is, what are birds doing in the southern hemisphere? Because, right, they're not seeing the North Star. So
I have a question.
sure.
Do birds migrate more on nights when there's a lot of moonlight, like a full moon or a gibbous moon? And has that been tested, in the planetarium to see if they orient better to the moon?
It's a great question. I don't know in terms of songbirds, which is interesting. I know we did a study myself. This is out with live cormorants, actually. We looked at whether or not they move more at full moons because it helps them but in that case, because they were foraging at night. But I don't know. Birds are mostly, what drives bird migration primarily is wind. Like, is the wind in the right direction? Are we going to have a good tailwind? Is it good weather? So like if it's fall and you get those hot, sticky days with south winds, that's a headwind for a bird. Birds aren't going to move. But the minute you get that beautiful north wind with that first cool weather, that's when birds are going to be leaving because they get that tailwind. So it seems that birds are really using more wind and weather, lack of rain, to drive when they're going to migrate.
We have a chat question here.
Thank you. I was going to thank you for sharing your knowledge. I appreciate it.
There's a question from Peoria Astronomy. You cited research as vintage. What will be the newest and meaningful discovery?
Well, I mean, that's what I was saying, like sort of the big things are trying to figure out how birds are using that magnetic compass and how birds are switching to, right? So when the magnetic compass also becomes kind of useless once you get to the equator. So it's sort of how are birds taking all of those different compasses, the sun, the moon, and the stars, and how are they using them? What takes priority and whatnot. So, and it's not my area of study, I should say. I studied primarily the health of birds. out in the wild and what they're eating. But this is something that's been, I find fascinating, and it's been an amazing way to look at, it's just an amazing way to look at bird biology, migratory bird biology.
Do you have any additional questions? Looks
Thank
like
you.
we run out of
Thank
questions
you.
to, and we had a thank you chat message from TCAA. Thank you, very fascinating presentation. I think we will confirm that here at Butterworth Center too. Thank you very much. I learned a lot and appreciate all the effort you did. And I'm almost impressed by your understanding of the astronomy and connecting that with your field study. It's very interesting. Thank you.
Well, thank you. Thank you for having me. I appreciate it. It's fun.
Okay. You stop your share. I will go back to sharing. Right here. Thank you very much, and we will.
I appreciate it too.
Yes,
Well,
thank you. And I'll say goodnight then to everybody. So
Good night.
Good night. We love you.
Very nice.
thank you.
Good night, thank you.
Thank you. Bye.
Thank you.
Thank you.
Night.
I'd like to move on. Usually we have some member observations, and well, I think we're all aware that recently the sun has come out of a relatively inactive period, has started having a little more action, and Al has been busy observing those sunspots as they come up. So I'd like to share your sunspot observations, Al.
Yeah, let me see if I can do that here.
These are sunspots. Al's been taking pictures of sunspots.
Really?
Yeah, here they are.
Okay, so I've got about a month's worth of pictures here. And I tried to take advantage of just about every opportunity, although I didn't get every day. But January 11th, I set up a telescope right on my front porch. All I got to do is just open the door and put it on the porch at around noon or early afternoon, and it's perfect. I don't even have to hardly put my coat on, even in the winter time. So this is my wintertime observing project. But anyway, on January 11th, I took this picture here. This is using a ETX 90 telescope. So this is a small telescope. Maybe I'll bring that in next time if we have need for a smorgasbord topic. I can bring it in and show you how it works. It's very simple, and I connected my DSLR camera to that, and this is a 1/1000th of a second time exposure. So anyway, you can see about what 4 or 5 sunspots there along the south portion of the sun. And then now this is just 2 days later. So between here's January 11th, here's January 13th. See how far those sunspots have rotated. And on January 18th, you can see they rotated some more, and there was some more sunspots over here, evidently on the right, that formed, I think, fortuitously. Then this is on January 28th, and there's a very interesting grouping of sunspots, a cluster of sunspots, I guess if you want to call it that, up there in the northern hemisphere. And then this is January 30th. So you see how far that sunspot cluster moved in 2 days. And it got a lot more distinct. Now, I don't know if anybody can see this or not. You see this little blue dot right there where my cursor is? Now let me magnify that a little bit. That is the Earth at the same scale. Now, obviously, we can't take a picture of the Earth from the Earth and show it this way. I basically I took a picture of the Earth and threw it out there at the same scale as those sunspots. So you can see how immense these sunspots are. These sunspots are actually much larger than the Earth itself. And I challenged some of the astronomers in the region here, and I think Carl Wenning, I don't know if he's on the line here tonight from TCAA, but I challenged him to see if he could actually visually see this sunspot cluster, and he said he could without a telescope. So I would have to admit I couldn't really see it. I tried, but somebody that's got a good imagination probably could. This is February. This is February 5th, and I tried a different telescope. This is using a 10-inch Meade LX200, and this is a different solar filter, so you get a little bit different coloration. But there's a whole bunch of sunspots out there, small ones, one big one and a bunch of small ones. Then this was February 9th, and I was playing around with my camera. Ken Boquist suggested I try mono mode with my camera. I have not done that before. And mono mode is monochrome, so there's no color there. And I think he's right. Use monochrome. Maybe the clarity of the images are a little better. Obviously, you don't get color. And then this was the 13th of February. That was yesterday. And here's today. So now you can see how far the sunspots rotated in one day right there. Pop back and forth. Sorry, I don't have tomorrow yet.
We'll be working on that around noon.
Yeah.
Would any of these sunspots that we're seeing, if any of them been strong enough to have created that storm that knocked down SpaceX satellites?
Maybe. Yeah. Particularly, let's see here. I would guess that this cluster right here, I'm going to guess, but I would say that cluster somewhere between the 20. When did that happen? You know?
We just don't know what I thought.
Well, see, that might have been the cluster that caused it because they're pointed towards the Earth, and so there could have been an expulsion of charged particles from that cluster, and who knows?
That almost looks like helicopters flying across the sun.
Yeah, you can see possibly the rotors on that.
But you know, for several years there haven't been any sunspots, and now there's all kinds of activity on the sun. So this is one of these things. You know, if you don't like cold weather, like I'm getting to be that way. I don't like cold weather as much as I used to. This is something you can do even in the wintertime, and it's not too bad. That's all I got.
Okay.
Are those actual sunspots there?
Yeah.
Yes.
Yeah. This is real.
Wow. I thought for sure there were helicopters.
Okay, thank you, Al. Does anybody else have any astronomy observations for tonight?
You know.
We have Dino here. Dino will have a few comments.
Yeah, I'll do something. Can you bring up our website, please, and share it on the screen so people can see it?
Here now. Come on.
What is that?
Should be able to share our popular astronomy club.
There we go. And then
Them all at once, but you can eat them all at once.
Yeah, I'll eat them.
articles and documents, please click on articles and documents.
At a time.
Info and presentations. And then right there at, excuse me, where is it? Background in the Rotary, keep going down. Let's see it. What is this? No, I don't see it up. I shall put it up for everyone instead. So there-
Good.
I don't see it. That will put it up for everyone. Well, I put the Rotary image up instead. All right, I'll put this up instead. Now, from our previous newsletter, we have something in there. There have been 2 deaths in the last month, one of which affects astronomy and one affects me personally. And so I'm going to talk about them quickly. The first one is regarding Iowa physicist Donald Burnett. My wife and I were in Iowa City on the 24th, and that day we had a newspaper article in the Daily Iowan pop up regarding Donald Burnett. He was a professor of astronomy at the University of Iowa for 60 years. Okay. He's worked with just about every project that they've produced over time. And as you know, the University of Iowa is one of the major sources for the equipment that have gone out in the satellites since the late 1950s through today. The photographs that they have of him are from 2019 and then from 1962 when he just started the program. And it shows actually the first satellite put up by the United States. Which one was that? That was the, and I can't remember the name, which was actually built with Dr. James Van Allen and launched in 1958. Since then, Mr. Gannett has brought in many people to work on the equipment, as taught the astronomy classes as well. He was actually there when I was there taking astronomy classes in 1976 and 77, although I did not take any of his courses. He has done a tremendous amount, and at some point or other, I've actually put the newspaper article up for people to see so that you'll have it and read. Otherwise, you can find a copy of it in our current newsletter, The Reflections, for February this year. Okay. That's the first one. The second one is my own father, Italo Milani, who passed away Sunday a week ago. It was buried today. Italo was 91 and an architect here in the area. And until a month ago, he was still working, still doing his thing. And just about every building in the Quad Cities, including some of the commercial buildings, if you go to a Starbucks in the area, he's had a hand in designing them and building them. And just about everything else as well. But he's also been a member who has attended a number of our astronomy events. For instance, the things at the 31st Street Library. He's been there a number of times. And out at Niagara Zoo, a number of people here will remember meeting him also. So he's an individual who's been active in many ways with the club, although not a club member per se. And if you remember some years back, my son Mitchell actually won the Cosmos Award, and we actually did filming at his house because much better perspective than ours, which was just
Another piece of cheese over here.
And so if you please remember my father, Italo Milani, that's I-T-A-L-O, first name, and his contributions to the club. And that's what I'd like to say, and thank you.
Thank you, Dino.
One little tiny piece.
Do we have any other observations or comments for tonight?
I have a comment, but not astronomy. Oh, hang on. Hang on.
Okay, I think we are waiting a minute here for.
While we're waiting for Roberta, could we have Scott Johnson maybe take a minute?
Scott Johnson, are you there?
Yes,
Okay. Would you like to say a little bit about your upcoming program here? I believe you're planning a scout group at Loud Thunder.
yes, thank you, because I have to leave at 8:15 to go to the airport. So I represent the Boy Scouts of America. I am one of two people that operate the telescope out of Camp Loud Thunder. We have an observatory out there. I don't know if anybody's ever seen that. And in May on the 21st, we have a stealth day. It's a STEM event where we expect to have 200 Boy Scouts come out to camp with their leadership, another 30 or 40 people. And in the afternoon on Saturday, they roam about to various science stations. And always in the past, we've had one of our science stations out at our observatory. We break it into two parts. It's during the day, so we do a tour of the observatory. And then I do an outdoor event where I'll do different things every year. This year, I cannot make the event. And we're trying to find someone that can come out and do presentations for the scouts as they go through the STEM program. In the past, I've rebuilt a scale model of the solar system and we visited planets. We're just outside in whatever tools and things I need, I just get. And then they go inside with John Schaub, and he basically shows them the scope and how the building works and the rotations of the shutters and that sort of thing. And then at night we do a viewing. Hopefully the weather will cooperate. So I need a couple of people that can come out and do a presentation to Boy Scouts on that Saturday afternoon. And I know you have another event going, but we can't find anyone in our organization that has the astronomy skills to do that. I can answer specific questions if you want.
Okay, Scott, I think we have talked about this, and it looks like we will have 2 or 3 people that could be available for that afternoon to come out and talk. We would have to work out with you some more details on that, but we will be getting in contact with you and working out a schedule and what we can do. As you mentioned already, that is our monthly regular public viewing at Niabi Zoo parking lot. So we need to have most of our members there who are available to help with the public viewing. It looks like by having your program in the afternoon, we'll be able to get 2 or 3 to come out and work with you on presenting some kind of astronomy information at that time.
Well, I won't be there. I can work with the team up to that week, and then I am leaving the state. So they'll be on their own. John will be there, and but he'll be inside the observatory. So I can work with the team up till the week of.
We will then be in contact with you and work out some plans for that.
Okay, that sounds good.
Okay. Thank you, Scott. Anybody
Thank
else?
you.
For announcements or? Okay, let us move on then. There, moving on. We have some interesting things coming up here. Next month, on March 14th, we have a business meeting, a brief business meeting, followed by a smorgasbord of member presentations. I'll be saying a little bit more about that in a few minutes here, but it will be an opportunity for many of you to be a presenter here. Starting in March, we have our monthly Niabi public viewing, as we were just talking about. And expecting some good crowds for that this year. I know there's been people who asked me about it and are waiting for us to get started on that so they can come out to that again. In April, our meeting will be a presentation of fantastic space discoveries, theories of solar system formation Jim Kovac, Chicago Society for Space Studies. So that should be an interesting one in a couple months here. Again, in April, of course, we'll have another NIAB public viewing. May 9th, our program will be Technology for the Astronomical Community and More by Matt Dietrich, a Technical Services Manager at Planewave Instruments in Adrian, Michigan. Coming up in May also is the Natural Convention. People have been waiting for this. This will be the first convention that hasn't had to be canceled because of COVID, since we had our natural convention here in the Quad Cities hosted by us. So here's your next chance to go to a convention. And I looked at the program, and there are many interesting programs, presentations planned for that coming up in May. Okay, we again have a Miami viewing. In June, we have a presentation, Sky with Ocean Joined, Scaling the Stars at the U.S. Naval Observatory, 1830 to present. Looks like we'll have a little bit of astronomy and history with that one. Presented by Jeff Chester, Public Affairs Officer of the U.S. Naval Observatory. And then we'll be rounding out that month with another NIAB viewing and a popular event that's been occurring every year that we've been able to have it, the public viewing at the Linowick Forest Preserve Campground in Hampton. And that draws quite a few people from the Upper Rock Island County area and the campground there to our public program there. Well, that's what's coming up for the first half of this year. We're working on having some more programs, of course, later on in the year. So here's your chance to put these on your schedule and get ready for some interesting programs. We also have some opportunities here for members. As I mentioned a little while ago, next month we're having after a brief business meeting, we'll have the smorgasbord talks. You can share your favorite topic or talk about a publication or article you've read, observatory or museum you have visited, or if you find some interesting statistics or data that would be of interest to amateur astronomers. Well, here is your big chance to be a presenter. Typically, it's something you know about. Don't have to do a whole lot of preparation for that. And if you are planning to do that, let Dino know. His email and number are in the newsletter, so you can contact him. Let him know. He will be coordinating the presentations at the smorgasbord meeting, so we can have know how many and how long we can allocate to everybody. Typically, these talks last 5 to 10 minutes, and you can have slides. We can present them on Zoom or handouts here at Butterworth if we need to. The other thing we need are newspaper articles. These are submitted to the Dispatch, Argus, and the Quad City Times. We have been providing a monthly article for several years now to the local newspapers, and they communicate astronomy topic of interest to the general public. So typically they are 600 to 1200 words, and depending on how the newspaper will take it, they will do some editing, and whether they include pictures or charts or things depends on how much room they have in the paper that day. Also, our own newsletter editor can assist in preparing these for submission. So he would normally look at them and standardize anything. Newspapers have certain ways they like to see things formatted and such. Paul can help you with that. This is a good opportunity if you have a topic you're particularly interested in, want to share it with the general public here. It should not be extremely technical. We're not making this a technical article because it will be going to the people who are newspaper readers and have that interest in looking up at the sky. And usually the article has a theme to the topic. This past month, and I don't think it has been in the newspaper, it hasn't been in the Dispatch Argus yet. But,
I've been in contact with them, it should appear soon.
oh, okay,
They kind of dropped the ball, and it's a long
okay. They tend to put that in since it's astronomy and the stars don't really make new news every day. It's the days when other news may be slow and they have room for our article, but they've been pretty good at getting it in just about every month. Wayland had a very good article, and we also put that article in our monthly newsletter that actually showed up the other day. We scooped the newspaper on that one. On ours before the newspaper got it out. Thank you, Wayland, for a very good article, and we look forward to seeing that within the next few days, probably. Okay, the other way to participate is in public observing. Obviously, NIABE is the big monthly event that we have, March through November. And some of our club members, I would encourage you, even if you don't have a telescope to bring, or if you prefer, we have a couple of club telescopes. You can help out with the PAC Meeting, which is always there. You can help explain some of the other scopes that are there. We have another club scope or two that's usually set up, and you can just mingle with the general public that's there and talk about astronomy with them. You have some good information that they're probably wondering about. And while people may be in line to look through telescopes or just wandering around looking at, you can also help, even if you're not running a scope, to help welcome the crowd, NIABE, or the other public programs that we expect to have this year. We already know about the one confirmed at the line of which we'll probably have some in the planning with some of the libraries and other organizations around the Quad Cities. Do we have any other announcements tonight? Anything else to present? In that case, I want to thank all of you for participating in this. We had some good questions for the speaker, and we learned a lot about how birds use astronomy. Actually, more than I thought we would learn when I'm seeing the topic. I was very pleased with it, tonight's program. We have been recording, and we will be placing that link to the recording on the website as soon as it is available, probably sometime tomorrow. With that, I thank you all for coming, and remember to keep looking up. Good night.